Hello guys, welcome to my channel. In today's video I'll be showing you how to make a Vhdl code for full header in structural style. And also I'll give the code for the test bench. So let's get started. First I'll create the files for the main code and the test bench. So let me first create a new project. I'll name it fheader for the full header. Let me just select a okay. Now I can make the Vhdl files. So fheader slash tbtv for test bench. Okay, let's open the file. Start with the code. First I'll import the library. So library IEEE, and the package we are using is standard logic. So IEEE dot standard logic for dot all. Alright, now I'll make the entities. The entity is gives us the input and outputs for our circuit. So entity. The name of the entity must be same as the Vhdl file. So fheader is so the inputs you can see here are A, B, and C in. So A, B, and C in. These are the inputs and their type is standard logic. Okay, and the output are sum and carry out. Say cout. Let's just give it a capital S, and we are done with the entities. Let's end it and fheader. Oh, sorry about that. Okay, now let's go with the architecture. We are using structural style, so strc. I always forget the spellings, doesn't matter. Of is okay. Before I begin the architecture itself, let's deal with the components. So in structural style, we make components to reuse them again and again in our code. So first I'll make the components for the two XOR gates, then the two AND gates, and the OR gate. So let's go with the XOR gate first. Component XOR2, since there are two XOR gates. Let's give them our inputs and outputs. So A and B. Let's give them A and B as the input and type standard logic. The output, let's say, is X. Okay, and this component. Okay, now for the AND and OR gate, I'll just copy this. Okay, this will be AND2, this will be OR1. Okay, now that we are done with our components, let's deal with our signals. Now the signals are like these wires that are connecting the two gates to each other. So this XOR gate is connected to this one via this wire. So I'll name it S1. Similarly for this AND gate, I'll name it S2. And for this one, the S3. And I'll define them in our code. So signal S1, S2, and the S3. The F type are std logic. Okay, now we can begin the architecture. Okay, let's first deal with this XOR gate. So name it U1. XOR2 port map A. So here the first A is the A we defined in the XOR gate, this component, sorry, XOR component. Here this one is the A, and the second A is the A we defined the entity for our main file in this one. We need to connect them for our code to work. So let's connect B with B, and finally the output X will be S1. You can see that the output of this XOR is S1, so name it X1, S1, sorry. Now let's just copy, paste this a bunch of times. Okay, let's change their numbering. Okay, now let's deal with the AND gate, specifically this AND gate. So it doesn't matter what's the order here. I can go for the second XOR gate or this AND gate, it doesn't really matter. So for this AND gate we have the inputs as A and B, and we get the output S2. So A and B remains the same, and the output is the S2. Now let's go for this XOR gate. So the inputs are S1 and the carry in. So S1 Cin, and the output we are getting is the sum. Now let's deal with this AND gate. The inputs are S1 and carry in. S1 carry in, and we are getting output as S3. I forgot to change its name. It's N2. Okay, now finally we can deal with this OR gate. OR1, the inputs are S3 and S2, and the output is carry out, C out. Let me just recheck. Yes, it's C out. Okay, now let's end the architecture. I forgot the spellings again. Paste this. Okay, now let's compile this so we can see if we get any error. So compile selected, and we get an error. Let's check what the error is. Okay, compile summary. Okay, so I forgot to save the code first. Let's compile this again. see what's the error again. Looks like there's an error here. Okay, forgot to tell it's the out standard logic. There we go. Save, compile. Okay, we got the green tick, so we are all good now. Okay, so let's now first make separate files for these components. So right now this code does not know what these components mean or what they do. So we'll have to make separate files and tell the code what these do. So let's make some new files. Their type will be Vhdl. So first I'll make for the XOR2, another file for the AND gate, and 2, and lastly the OR gate, OR1. Okay, let's do for the XOR first. Let me just copy some of this. And paste here. This is the XOR2. Now keep in mind this should be the same as the entity we defined in the component XOR. So I'll just copy and paste it. And then XOR2. Okay, now here's the architecture. And now forgotten the spelling again, ARCHITUCTURE. What I am doing wrong? What are the spellings? ARCHITECTURE, I'm sorry. TECTURE, there we go. Architecture, style is structural, of XOR2 is begin. So the output X is the XOR of A and B. There we go. And we need to end the architecture. Hopefully this time I write the spellings correct. ARCHITECTURE. And I messed it up again. There we go. Now save, compile. Is don't okay. There is no error, so I'll copy this and paste it in the AND2. Just rename it AND2 AND2 and here it's and okay, looks good. Let's compile it. Come on, there we go. Similar procedure for the OR gate. That's OR1, OR1, and OR. Save it, compile it. Okay, so the last step is our test bench. So let's get started with the test bench. So I'll need the library and the package. I'll just copy paste them. Next, I need to create the entity. So as I explained earlier, the entity defines the input and output of our design, but in test bench we have no input and output. So I'll have to create an empty entity for the test bench. So entity, name it, similar as the file name, and just end it. There we go. Okay, now let's deal with our signal. So here and we'll declare our signals for test bench. Signals will declare what are its input and output components. So signal A, B, finally scene. I'm keeping same as the main Vhdl file, the Fheader, to keep things simple. And logic. Sorry, yes, I was doing right. Yeah, I see. And again, for the output, you can make this in one go. So you can declare the output signal in this one as well, but I like to keep them separate. So the output are sum and carry, C out. There we go. So now we need to make a component, and this component must be same as the entity we defined in the main Fheader Vhdl file. So I'll just copy and paste this. So copy and paste, and component Fheader. This name must be same as the main file of our project. So and let me just confirm we are doing it correct. Okay. There we go. Now let's begin our architecture. So Vhdl. So now we have to create an initiation of our design under test. So Fheader is our design under test, and we'll have to link its components with the components of the test bench, which we declare in the signal declaration. So let's link it first. I'll name it as DUT1 Fheader port map, and now we'll link them together. B is connected to B, Cin is connected to Cin, and Cin, let me give it a space, sum, and finally our carry out. Okay, now let's begin our process in which we are going to give the A, B, and C in some values against which we'll get the output sum and carry. So first I'll name the process. And begin the process. First input for A, for B, finally for Cn. And we'll wait for about, let's say, 15 nanoseconds for it to complete. Wait for 50 nanoseconds. Okay, let's just copy and paste this for a few times. I'll need to paste some more. First, let's just fill this. So 001, 010, 011, next is 100, then 101, paste it a few more times. Okay, 110, and finally 111. Let me count them: 1, 2, 3, 4, 5, 6, 7, and 8. So 3 inputs, 8 combinations. Okay. Now let's end the process and end the architecture. Save it and then compile it. And we have an error. Let's see. Okay, I forgot that the signal and components are under the architecture. So here, again, I forgot the spellings. Architecture, Vhdl, and let's just name it test bench of Vhdl. Test bench is Vhdl test bench is okay. Let's compile. Hopefully we don't get any error. There we go. This yellow thing means warning. We can ignore that. Let's go to our library, work, and let's just double click this. It takes some time. Okay, now add wave in region. There we go. So in the code and the test bench, we used 15 nanoseconds about, let's say, 8 times. So multiply 50 with 8 and we get 400. So I'll run the simulation for 400 nanoseconds. There, and run. Oh, and there we go. Let's group them It was compile signal or group. Let's see. I think it's compile signal. Sorry, combine signal. Name it inputs. There we go. And these are the outputs. Doesn't matter. For 000 it's 0. 111 sum is 1, carry is 0. You can match these with the truth table. And let me take out the truth table for this. Okay. Let's zoom it full. There we go. So for 000, the sum is 0 and carry out is 0. There we go. And 000 sum is 1, carry is 0. Sum is 1, carry is 0. And let's choose a random one. 101. Here 101. Sum is 0 and carry is 1. Sum is 0, carry is 1. So you can compare the rest of these with the truth table and see if it's working or not. I think it's working, and hopefully the video is useful for you, and if you find it helpful, please consider like and subscribing my channel. It helps me a lot, and I'll see you in the next one.